Right. I have been thinking about thread dials, and I might have come up with something marginally interesting. Now, thread dials for the Lorch, because the Lorch doesn't have one. It's a metric machine, and people who go, "Oh no, you can't do thread dials on metric." And it's true that a thread dial on a metric machine is slightly more complicated than a thread dial on an imperial machine. It's one of the few, very vanishingly small number of cases where metric is more complicated than imperial. There's reasons for it. The reasons for that are that when you're threading in imperial, you are measuring the number of turns per inch, as opposed to in metric, where you're measuring the number of millimetres per turn. And the whole thing's turned on its head a bit, and it's much, much easier to do on an imperial machine. Now here we have a drawing of basically the basic guts of a thread dial. You have a gear with a shaft, and then on the top of that we have a dial. And for a metric machine, you can't just have one gear. Well, you can, but this is what we're trying to get around. You need different sets of gears, different gearing, depending on which thread you're cutting. On an imperial machine, you have a lead screw which is typically 4 threads per inch or thereabouts, and because all of your threading is done in terms of threads per inch, you can have a dial which has a 1 position on it, and at the worst case, if you always engage on the 1 position, you're pretty much always going to be good. Until you get above 1 inch threads, and then things get a little bit more complicated. If you want to look at a fairly classical metric threading dial setup, you could do a lot worse than looking at Harald Finster's videos. I'll link them below. They are very, very good, and they explain the mathematics of a metric threading dial in terms of advance of the lead screw and advance of the thread that's being cut. It's a nice way to think about it, and it works very well. He does a very good explanation in his first video, and his thread dial's really nice. But it's the classic style. He has 3 gears which slide up and down this shaft, and he's got a little detent that lets you click them into place. It's a bit of a pain in the hole. They're a bit of a pain in the hole to use, metric threading dials. Another set of videos that are worth looking at, or in fact a video which is worth looking at, comes from a guy called An Engineer's Findings. And he's made a thread dial which works differently. It has 1 gear at the bottom and 3 separate dials. And his dials let him do thread indications for metric and imperial threads. So he's got a bunch of gearing at the top and 3 separate dials. And that is another way of doing things, but it's a bit complicated because you've got 3 dials at the top. You need to know which dial you're looking at, and which indicator you're looking at, and all the rest of that good stuff. But it does do imperial as well, using the 127 tooth gear. It's quite big. But his video is very, very good, and he explains in terms of what he calls the threading equation. The threading equation being, or the threading conditions, the conditions in which you can engage the lead screw, engage your clasp nuts, and be in your thread. So that's very worth looking as well, also linked below. Now, I'm kind of wanting to do something very similar to what he's doing, but I want concentric dials. So first thing we need to look at is what is complex about metric threading. Well, I've got a little spreadsheet here if I can make it visible, just there, and I'll make it visible for myself on screen. No, that's not it, is it? That is though. Right, so this spreadsheet works from an engineer's findings setup. Here we have the various pitches of metric threads, including the Schablin drawbar pitch. So from 0.2 all the way up to 6. There are smaller, there are larger. This is set up, this is all calculated for my lead screw, which is a 3mm lead screw. Bigger lathes tend to have a 6mm lead screw. You need to recalculate this. And these first two columns here, or these not first two columns, but these two columns here, are the results of the threading condition as defined by an engineer's findings. I don't know his name. So this is the lowest number of turns of the lead screw in which you can engage. Now, anything which is any pitch which is a divisor of the lead screw pitch can be engaged anywhere it likes, which is why we get ones here, and why I've put stars over here rather than numbers, because they just confuse things. So we can ignore these. So that one, bloody OpenOffice. So, yeah, these ones we can ignore. Seven 5 we can ignore. 1 we can ignore. 1.5 we can ignore. 3 we can ignore. So all of those, in fact, let's make those grey, so we can ignore all of those. But for the other thread pitches, some of which are very, very useful, we will need to either use a threading dial or threading by repair, which is where you set up a carriage stop and mark your lead screw, and is a pain in the hole, or just keeping your lead nuts engaged and going backwards and forwards, which is also a pain in the hole. Now, the typical setup for a metric threading dial uses 14, 15 and 16 tooth gears on the bottom, which you change. That's because we are chasing factors of 2, factors of 3, factors of 4, factors of 5 and factors of 7. And you will notice that 2, 3, 4, 5 and 7 very neatly divide 14, 15 and 16. And what this means is that, for example, for a 1.25 pitch thread, you would use a 15 tooth gear and you could engage 5 times on that 15 tooth gear, so every third tooth of the gear. So on the dial you would have 5 marks. Not necessarily. There's reasons for that too. Because a typical metric threading dial only has 1 dial and 3 separate teeth, it would get very, very cluttered if we had 7s and 5s in there. So 7s and 5s just get pushed down to once a turn. In the conservative sense, that will always work. It will slow down threading because you have to wait for the dial to come all the way around before you can re-engage, whereas you could potentially have re-engaged 6 times beforehand. No big deal. And again, if we look at a 4.5mm thread, well no, let's look at a 4mm thread on my lead screw, you could engage 4 times on a 16 tooth gear, so every 4 teeth. Okay, but what you'll see is that 5.5 is not covered because 5.5 has a factor of 11, and 11 is a pain in the arse. Now there's another set of gears that you could use. You could use 20, 21 and 22. You could use an 11-tooth gear, but the 11-tooth gear is generally undercut. They're very small. So 20, 21, 22, you could use those. The downside to this, because they cover the same, well, 20 and 21 cover all the same factors as 14, 15 and 16, and 22 covers the 11. The downside to this is that if you have one dial, rather than waiting in the case of, let's say, a 1.25 thread, which would be, you're waiting for this 15-tooth gear to go round. You're waiting for this 15-tooth gear to go round once. You'd be waiting for the 20-tooth gear to go round once, and that is slower. So it's generally why those aren't used. But with 20 and 21, you can get away with it. Now, there's another way you could do this. You could actually make two threading dials. One with a 20-tooth gear on the end of it, and one with a 21-tooth gear on the end of it. And you could set up on the 20-tooth gear, you could have the 4 and 5 indications, and on the 21 you could have 3 and 7. And Robert would be your mother's brother. But that's two separate things. You can make a quick release, I suppose. And that would be quite simple to do. That's not what I'm talking about doing. So let's go back to CAD, which is here. So let's hide my little spreadsheet and we go back to CAD. Right. So in this CAD model we have we have a 21-tooth gear here at the bottom. This is a 21-tooth module 1 gear, which is going to engage quite nicely with my lead screw. And on the top of it, we could put a dial, and we'd be done for the 21. We could put the dial with the 3 and the 7 on it, and there you would be. But what I'm doing instead is I'm going to put, hopefully if this is going to show, I'm going to put another 21-tooth gear on it. This is a 21-tooth module 0.6 gear. Now what's that going to do? Well, that is going to engage with a 21-tooth driven gear, which has a dial on the top of it. And you'll notice that this dial has 1, 2, 3 marks, and it has 1, 2, 3, 4, 5, 6, 7 marks. So we're going from 21 to 21 to 21. This will turn synchronously with the 21-tooth gear at the bottom. Effectively, this is one gear. Now, let's hide that dial for a second. Now what we could do now is we could put a 20-tooth gear over here. And that's, I suspect, what an engineer's findings has done. He's put a 20-tooth gear over here with his second dial, and he has 2 overlapping dials. I don't want to do that. I want to do this. It's a bit cheeky. Here we have a 21-tooth 0.6 module gear, and we have a 20-tooth slightly more than 0.6 module gear. It has the same outer diameter as the 21-tooth gear and will engage with some slop in this 21-tooth gear. But this will now rotate 20 times. Because this gear in the middle is now irrelevant. We have a 3-gear setup. These 2 gears could be any size we wanted. Now this type of setup is used occasionally in orreries to have 2 concentric things which move at a very slightly different speed. And you could do the same thing with the 22 to get the third dial running as well. You could go 20, 21, 22, all engaging with the same 21 tooth gear in the middle. This doesn't have to be 21, it can be any large number, larger number that you wanted. Going smaller gets a bit tricky. So, what we end up with then is we end up with this dial and also a second dial. And this second dial has 4s and 5s. So we can indicate once around the dial, twice if we mark this one specially, 3 times with square holes here, 4 times with the hexagonal holes, I think they are, yes, 5 times with the triangles, and 7 times with the circles. And it's all in one relatively compact package. It's a bit of a pain in the arse to make, but you only make your threading dial once. You use it lots. And this should take quite a lot of the pain out of using the threading dial. You won't have to move gears around. You still have to remember which set of indications you're looking at, but apart from that, you're all good to go. Anyway, that's my idea, and I'm going to make one. Ciao.